Have you ever wondered how Newton's laws of motion have shaped the world of modern physics? Well, let's dive into the captivating life of Sir Isaac Newton, the man whose groundbreaking discoveries have become the bedrock of physics. Born in the 17th century, Newton's curiosity about the natural world led him to formulate laws that govern the motion of objects. These laws, known as Newton's laws of motion, have not only defined the path of physical science, but also revolutionized our understanding of the universe. From the way a soccer ball curves in the air to the orbit of distant planets, Newton's laws are the guiding principles. In the realm of modern physics, Newton's laws have provided the foundation for many significant developments, including Einstein's theory of relativity and quantum mechanics. Without Newton's fundamental laws, our understanding of the universe would be drastically different. So let's take a moment to appreciate the profound impact of this extraordinary man on our everyday lives. Born on Christmas Day in 1642, Newton's life was anything but ordinary. Hailing from a humble farming family in Woolsthorpe, England, young Isaac was thrust into a world of curiosity and innovation from a very early age. His father passed away before his birth, leaving him under the care of his stern yet loving mother. His early years were spent in solitude, fostering a deep sense of observation that later played a crucial role in his scientific endeavors. Newton's formal education began at King's School in Grantham, where he was introduced to the fascinating world of science and mathematics. He quickly developed a passion for these subjects, often engrossed in books and experiments, setting the stage for his future brilliance. Newton's journey to Cambridge University was a testament to his dedication and relentless pursuit of knowledge. It was here, amidst the hallowed halls of academia, that his genius truly began to shine. Newton's early life laid the groundwork for his groundbreaking discoveries. Newton's laws of motion, three fundamental principles, revolutionized our understanding of the physical world. Let's delve deeper into these laws, shall we? The first law of motion, often referred to as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by a force. Picture this. You're in a car that suddenly stops. Your body tends to move forward. That's inertia, my friend. The second law, the law of acceleration, is perhaps the most recognizable of Newton's laws. It tells us that the force exerted on an object equals its mass times its acceleration. Simply put, the heavier an object is, or the faster you want it to go, the more force you need to apply. Think about pushing a shopping cart. Easy, right? Now imagine if that cart was filled with bricks. You'd need to exert more force to get it moving. The third law, sometimes referred to as the action-reaction law, states that for every action, there is an equal and opposite reaction. Picture a swimmer pushing off from the pool wall. The force they exert on the wall is met with an equal force propelling them forward. These laws might seem simple at a glance, but they govern much of the movements and interactions we see in our daily lives. From the way vehicles move on the road, to the way we walk, to the flight of a bird in the sky, Newton's laws are in play everywhere. But their influence doesn't stop at everyday experiences. These laws are also fundamental in fields like engineering, space exploration, and sports science. They help us design safer cars, launch rockets into space, and even understand how a golf ball flies through the air. Newton's laws of motion are pillars of classical physics, and continue to be used in scientific research today. They serve as a testament to the timeless relevance of Newton's work, shaping our understanding of the physical world, and driving the advancements that continue to push the boundaries of human discovery. Newton's universal law of gravitation, another groundbreaking discovery, describes the force that binds the universe together. Quite a statement, isn't it? But it's true. This law, born from the mind of Isaac Newton, literally keeps our feet on the ground and the planets in their orbits. Let's dive in. Newton's law of universal gravitation states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simpler terms, this means that the bigger and closer the objects are, the stronger the gravitational pull between them. This law is universal, and it applies to everything, everywhere. It's why we stay anchored to the Earth instead of floating off into space. It's why the Earth orbits the Sun in a nearly perfect circle. It's why the tides rise and fall. It's the cosmic glue that holds galaxies together. It's the heartbeat of the universe. Now you might be wondering, how did Newton come up with this? Well, it all started with an apple. Legend has it that Newton was sitting under an apple tree when an apple fell on his head. This sparked his curiosity. Why did the apple fall straight down? Why not sideways or upwards? The answer, he realized, was gravity. Newton's universal law of gravitation was a game changer. It helped us understand the movements of the planets and the nature of tides. It paved the way for advancements in astronomy, physics, and space exploration. It even helped us land a man on the moon. But perhaps most importantly, Newton's law of gravitation taught us that we are all part of a vast, interconnected universe. We are bound to the Earth is bound to the Sun is bound to the galaxy, and the galaxy is bound to the universe. We are all, in a sense, bound together by gravity. Newton's law of universal gravitation forever changed our understanding of the universe. It showed us that the universe is not a chaotic, random place, but a beautifully ordered and predictable system. And for that, we have Sir Isaac Newton to thank. Newton's laws of motion and universal gravitation have had a profound impact on modern physics. As we delve into Newton's legacy, we see it is as vast as the universe he helped us understand. His pioneering work has been the springboard for countless scientific research and technological advancements. From the smallest atomic particles to the largest celestial bodies, Newton's laws provide a framework to decipher the mysteries of motion and gravitational forces. They're the fundamental principles that underpin our understanding of classical mechanics, the branch of physics dealing with the motion of bodies under the influence of forces. Consider the field of aerospace. The principles laid down by Newton guide the design and trajectory of rockets and satellites. It's his laws that help us calculate the force needed to escape Earth's gravitational pull, or to maintain a stable orbit, or even to land a rover on Mars. In the realm of engineering, Newton's laws are instrumental in designing bridges, buildings, and vehicles. They help us understand how forces act on structures and how they respond. In sports science, they explain how a curveball curves and a sprinter accelerates. Even in the field of quantum mechanics, which deals with the world of the very small, Newton's laws still hold sway. While quantum mechanics can seem a world away from the apple falling from the tree, it's Newton's concept of force that leads us to the idea of fields, which in turn leads us to quantum fields. In the realm of technology, Newton's laws have been instrumental in the development of GPS systems, which rely on an understanding of gravity and motion. They've enabled the creation of precise timekeeping devices and have even influenced the development of computer algorithms used in animation and gaming. Newton's laws are not just historical artifacts, they're living principles that continue to shape our world and our understanding of it. They're the language of physics. They're the tools we use to explore, predict, and manipulate our physical universe. Newton's laws are fundamental to our understanding of the physical world and continue to shape physics today. Newton's laws of motion and universal gravitation have revolutionized physics and our understanding of the universe. Let's recap the key insights we've explored today. We took a journey through time, tracing back to Newton's early life. A curious child, Newton's fascination with the world around him set the foundation for his groundbreaking theories. His laws of motion, three simple yet profound principles, have become fundamental to physics. They describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. Then we delved into Newton's universal law of gravitation. This law explains why the planets move the way they do, why the tides ebb and flow, and even why we stay grounded on Earth. It was a leap forward in scientific thought, providing a unified explanation for motion in the heavens and on Earth. We also discussed Newton's legacy. His laws have not only structured physics but also paved the way for future scientific advances. They have influenced disciplines as diverse as engineering, astronomy, and even philosophy. His work has shaped our understanding of the physical world and continues to inspire scientists today. But Newton's contributions extend beyond the realm of science. His laws remind us of the interconnectedness of all things. They show us that the same principles governing an apple falling from a tree also govern the motion of planets in space. They give us a sense of order in the universe, a framework to make sense of the natural world. So, next time you watch a leaf flutter to the ground, or marvel at the stars twinkling above, remember Newton and his groundbreaking laws. They're not just abstract theories tucked away in dusty textbooks. They're alive in every moment, in every movement, in every corner of our universe. Next time you see an apple fall from a tree, remember Newton and his groundbreaking laws. They're not just theories, but the very laws that govern our universe.